Hello, everyone, and welcome to today's webinar. My name is Toph Whitmore. I'm the Vice President of Marketing at Simba Technologies here in Vancouver, British Columbia. Today I'm joined by stakeholders from SAP's Lumira team and Concur. And we're going to talk about analytics at the speed of Spark, specifically how Concur looks at with SAP Lumira, Apache Spark, and Simba ODBC. Just a couple of quick administrative details. If you have any questions, please submit them via the chat or questions window in GoToWebinar, and we'll try to get to as many as we can on the call. If we can't answer them or don't get a chance to answer them on the call, we'll try to follow up with you to give you more details. With that, let's start with some brief introductions. Today I'm joined by Angela Harvey. She's the Director of Solution Management for Big Data and Analytics at SAP. She'll start off and give us an overview of SAP Lumira's business insight capabilities, particularly as they relate to data sources like Spark. I'm Toph Whitmore. I work at Simba. I'll be giving you a quick background on Simba ODBC connectivity, particularly as it relates to the Concur use case. And then finally, for the bulk of the presentation, we'll hear from Denny Lee, who's the Senior Director of Data Sciences Engineering at Concur. Denny is a Spark early adopter and also the leader of the Seattle Spark Meetup group. So with that, let me turn it over to Angela, who can introduce you to SAP Lumira. Angela?
Great. Thanks a lot, Toph, and thanks everyone for joining us. Like Toph, I'm responsible for our big data strategy as it relates to analytics here at SAP. So we're going to spend the bulk of the time going through Denny's use case because I think the Concur example is a really fantastic one, and I think you'll enjoy hearing more about it. But for those of you that aren't familiar with SAP Lumira, I wanted to spend a little bit more time talking about that. So when we look at traditional BI solutions, they were built for IT and end users were the consumers. But we've really seen a shift in the market where end users want to do their own data exploration without having to burden IT and without IT wanting to be burdened every time they need a new report or need to write a new query. So that's where SAP Lumira comes in. It's really a tool targeted at power business users and business analysts, and it allows them to merge data from different sources, build visualizations, and then share it with their teammates. The other thing I want to call out there, though, is you're probably familiar with the business object solutions. The nice thing about Lumira is it really does empower the end user to do that data exploration and management themselves, but they can trust the data. So it's one thing to not rely on IT. But back when I joined Business Objects in 2005, our mantra was really a single version of the truth and talking about how universes and the semantic layer enabled that. And it's funny because as we've moved to empowering the business user more, we've kind of gone back to these data silos where people are working off Excel spreadsheets on their desktop. So with SAP Lumira, you can actually govern it through BOE if you wish, or it can be standalone. So for IT, it's great because they can audit what's been done and govern who has access to what data, but end users can be confident in the quality of the data. So with that, I want to quickly move into a few of the key capabilities of Lumira. So I did mention you can access data from a variety of sources, and of course we'll be going through the Spark example today. And this is where the Simba drivers have really enriched Lumira and made it really seamless and out-of-the-box connectivity to all the usual suspects for data sources. So even as an end business user, you can just point and click and merge your data. The other real differentiator with Lumira is this transformation column. We've got the prepare room. So in addition to merging your data, you can really enrich it in the prepare room. Cleanse the data and do all those manipulations, kind of similar to like you could do in Excel without any need for scripting or to know SQL. You can do things like create date hierarchies. So one example there is if you had a column that had all the actual sales dates, you could have Lumira extrapolate that out into quarters, months, and kind of the typical date hierarchies that you may want to visualize something in. So all of that transformation and data enrichment can actually be done within the Lumira tool. For the visual discovery, Lumira is a very engaging, easy-to-use end-user tool. But I know Denny's got some great screenshots in his examples, so I think rather than speaking to visualizations, it'll be better if you just see them. And then we do have a few different sharing options. So you can share them through Lumira Server, and that's offered on-premise as well as for cloud. And then, of course, through the BOE platform as well and through SAP HANA. So without belaboring Lumira before, I'm happy to share it in action with you by passing over to Denny.
Actually, Angela, it's my turn. This is Toph.
Oh, I'm sorry, Toph.
That's okay. I'll hand off to Denny very briefly in just a moment. Just want to provide a little quick background on Simba. We're the connector here, and so we're an enabling technology that's under the hood. And for those of you who are familiar with Simba, you may know a little bit of this already. But for those of you who aren't, I'll go very quickly so we can get to the use case here. Pick your metaphor. Simba is the bridge, the glue, the plumbing, the on-ramp to big data, connecting whatever data source you need with the business intelligence tool that you're using, in this case, SAP Lumira, providing better data insight via the your application of choice from whatever data source you're connecting to. Today we're talking about Spark, but Simba also provides ODBC and JDBC connectivity for really, you name it, Drill, Impala, Hive, HBase, Cassandra, MongoDB, DynamoDB, Presto, Google BigQuery, Salesforce, HANA, you name the data source, and we probably have a driver for it. You can learn more at simba.com, end of marketing spiel. But a couple of quick fun facts about our company. We are the de facto standard for Spark ODBC connectivity, and it's nice as a marketer to be able to call out two companies who license our technology. SAP Lumira and Databricks both license our technology and use us for Spark connectivity. And the other thing is that we've been around for a while. We drafted and created the original ODBC standard with Microsoft back in 1992. Some of you may recognize the old Microsoft logo. You can kind of see what I did there. I, for one, happen to be old enough to not just remember that logo, but the one before it. And then finally, this is the view from our office. We're looking at this right now, frankly, and I put this here just in case anyone is interested in coming out to Canada and working with us or for us. So, quickly, a context diagram to set up Denny's demonstration. I talked about Simba being kind of in between the business intelligence tool and the data source. In this case, we're in the middle there, the gray and red part. We provide the ODBC connectivity between SAP Lumira and Spark. And one of the things that's really a key value proposition that we bring to this relationship is our SQL translation. I talked about the metaphors. In a lot of ways, we're also a universal communicator. You have a workforce of analysts, an analyst community that can leverage their existing SQL knowledge without having to learn a new SQL language. So in this case, we translate Spark's anti-SQL queries into Spark SQL and back again. Now, that's a very valuable tool when you are pulling data from multiple sources. You can become an expert in Lumira and not have to necessarily learn Spark SQL and leverage your existing query knowledge and expertise. That's very valuable for Spark. It's also valuable in particular for NoSQL data sources like Cassandra or MongoDB. And then finally, we support whatever kind of architecture you're setting up, whether you're on-premise or in the cloud when it comes to Spark distribution. And now finally, the more important part of the show, let me hand it over to Denny, and we can see Spark and Lumira and Simba in action. And hang on a second here while I make Denny the presenter. You ready to go, Denny?
Absolutely. Well, hello, everybody. Thank you very much, Toph, for those kind words. I'm representing Concur today, and we are talking about Spark, Lumira, and Simba at Concur. Again, my name is Denny Lee, Senior Director of Data Sciences Engineering. So let me start off a little bit about Concur. So what do we do? So we're the leading provider of spend management solutions and travel, invoice, TripIt services in the world. We have a global customer base of about 20,000 clients and 25 million users, and we process more than $50 billion in travel and expense spend each year. You might know us or recognize us using the traditional Concur logo that you're seeing here, or the TripIt logo, which helps our business travelers make sense of their travels and expenses. So one thing I did also want to note was that while Concur was acquired by SAP at the end of December 2014, we've actually been working with Spark for more than a year and a half. Okay. Now about the speaker. Who am I? So as Toph and Angela have quite noted, I'm at Concur as the Senior Director of Data Science Engineering, but I'm also a long-time SQL Server BI guy, actually. In fact, if any of you have ever worked with analysis services or traditional OLAP technologies, I had helped the team at Yahoo build the largest analysis services cube in the world at 24 terabytes. The cube itself was 24 terabytes. The source of this was actually 2 petabytes in a 14 petabyte Hadoop cluster, about 6,000 nodes. So pretty cool. Shortly after going ahead and helping to build that, I also was on the incubation team at Microsoft that helped build Project Isotope, what's also known as Hadoop on Windows and Azure, and currently known as HD Insight. And in my new life right now, I'm at Concur helping with big data and data sciences. And so as a quick note, some of the people have asked me in the past, no, I'm not wearing a robe in that picture. I'm actually wearing a lab coat. That's a long-time SQL cat joke, but that we were the SQL doctors, and hence the lab coat. This is just me being silly. And also, another cool note is that I've been a Spark enthusiast since around Spark 0.6 days. So pretty cool. All right. So let's jump right into the themes of things, though, okay? Because we're going to sort of group everything together within the context of when it comes to these big data and data science systems, we're first going to consolidate the data from multiple data sources. That's an important aspect because you're typically not dealing with one, you're dealing with many different data sources. Then you're going to have the ability to visualize that data. This is a very important aspect of why Lumira is such a very powerful tool. But because we're using Spark, we're not just able to visualize, we're able to gain insight into this data. And we're also able to provide some recommendations. So the themes throughout the session is going to be basically broken down to that. A little hint on the top right of the slide, you'll actually see a little logo that sort of indicates whether we're talking about consolidation, visualization, insight, or recommendation. So let's start off with a long time ago. In the beginning, actually, our entry into the big data space from Concur was actually not terribly ambitious. In fact, we started using Hadoop because it was free. Our industry is actually a notoriously frugal industry, so we weren't going in there with some ambitious result of recommendations or insight. We were going in basically to build cheap reporting. That's really all it was. What we did actually is that we spun up initially actually about 10 or 12 nodes just for the purpose of that were very old. They were pretty old boxes at the time. And we extracted the data from multiple SQL servers that we had, and multiple relational data sources for that matter, and merged them all together and consolidated all that data into the Hadoop cluster. And like I said before, cheaper reporting. We weren't thinking advanced analytics. It's just more like, hey, we've got these boxes lying around. It'd be nice to go ahead and actually deliver some reports off of it. And so, but over time, right, it actually wasn't just about our data. We started with the expense data here actually on the bottom, if you'll notice there. And what happened is that while we have that, over time we actually added travel data on the left side, and we also added invoice data, which is our sizable amounts of data sources that we have within our production environments. And so we initially just started with the concept of saying, okay, I'll go ahead and build Hive on top of, excuse me please, Hive on top of these, what is actually traditional relational data sources, and because I wanted something cheap, I could just drop the stuff right into Hadoop and make sense of the data. That was pretty much it, okay? And the reason why we actually were focusing on travel and invoice combination with expense is because actually the #1 line item in your expense report typically was travel. And then a very important line item also in your expense report was also the invoices. So the combination of the three together made a lot of sense. But what made things a little bit more interesting and why Hadoop was more powerful wasn't just because we could take a bunch of relational data sources and put them together. It was because we actually could go ahead and take lots of non-relational data sources, like weather data, like our web analytics data to understand how people are using our product. The Bureau of Transportation Services, which contains a lot of really cool information like flight delays, flight arrivals, security wait times, things like that. So combining all of that together, i.e. the consolidation of all this data, actually became vitally important for us. And that's actually how we started in the big data space, or the Hadoop space. But then over time, we actually wanted to go ahead and actually be able to look at that data. It's not just about reporting anymore. It's about actually visualizing that data and gaining quicker, faster, better insight on the data we have. Okay, so by using Lumira, here's a screenshot of actually Lumira right away here. It allowed our analysts to actually quickly ascertain the travel segments by the country by quickly placing this information into Lumira. Our analysts were able to easily understand what are the predominant origin or destination travel segments, where they basically are going by country, and by quickly viewing that Lumira map that you're seeing right in front of you. And so while we can easily see that our home market of the United States contains the vast majority of travel, we can also just as quickly see that countries like Canada, Brazil, China, India, Australia, and various countries in Western Europe were actually very fast-growing markets. If I actually trended over time, you would actually see that. But what's also interesting about Lumira was that it was not just the value of working with Lumira, the fast visualization. It was also the ability to quickly create hierarchies and help us wrangle our data. You'll notice that when Angela spoke earlier in the session, she was talking about the ability for us to prepare that data. Well, here's an example of us actually preparing that data. Actually, we're more in the visualizations aspect, but we're preparing by actually creating a geographic hierarchy. And so what you'll notice here is that within Lumira, I'm able to go ahead and take the country code information that is actually stored inside my data within Hadoop in this case, okay? And I'll be able to create a geographic hierarchy with it by the names or the country codes. And in this case, since I only cared about country, I didn't care about region or subregion, I specify very clearly here that the geographic dimension I'm working with is based off the country code. But what's really powerful is also the data wrangling aspect. And so what you'll see here, if you look at the screen here, is that there are 25 distinct country codes that were actually in this particular data set. 24 of them were quickly solved. For one of them, we have no idea what it is. In other words, there's a country code of JE that we actually don't know what it is. And Lumira was able to actually quickly show that to us so we can understand, okay, well, there's a country code of JE. It's not found. What do we do about it? Now, further down in our analysis, we were able to figure out that it's actually JP, and those are typos, so we just fixed it. Not a big deal, but it's things like this that allow us to allocate, assign, and understand what's actually within our data. And this allowed our analysts, not our IT crew, not our engineers, our analysts to go ahead and quickly wrangle their data and quickly decide what data they needed, what data they had to resolve, and what data to exclude. And when you put this all together, basically we can harness Lumira against our big data cluster to make better sense of this data. But how do we make it run really fast? That's actually the usual question. And the heart of how we did that is through Spark, okay? So while Lumira is able to allow us to analyze, extract, wrangle, visualize, and create those stories around the data, how do we get the data so quickly into Lumira in the first place? We did start with Hive, but quickly went to Spark because of the key power of Spark SQL. We harnessed the power of Spark to make things run significantly faster. And so let me give you a quick example of what I mean by that. So how fast do I say? So if you look at this, the row counts against, like, let's just say I have 1 million plus categorized receipts, and this is commonly something that we're usually looking at. And if you look at me running this in Pig or in Hive, basically the first query ran in about 41 seconds. The second query, just to do a quick row count of all the receipts that I have, it took about 42 seconds. In Spark, on the other hand, it took about 2 seconds for the first query, and the second query ran in 0.5 seconds. In this case, we're actually able to make use of in this case, Spark has a concept called RDDs, Resilient Distributed Data Sets, which float in memory. So provided there is enough memory, you can take your query, it'll go into memory, and then subsequent queries against that same data, in fact, actually make use of that cache or make use of that RDD that's floating in memory. So subsequent queries against the data set, in fact, are going to be even faster than the original query. But as you can tell, the original query was pretty fast anyways. And so if I also use a word count, again, a very simple concept, but nevertheless very important. If I was to do this in Pig or do a Hive equivalent of this, it takes about 2 minutes 9 seconds, 2 minutes 7 seconds for the first two queries. If I did it in Spark, 38 seconds for the first query, but even faster, 2 seconds for the second query. So they're even faster. So that's pretty cool, right? So that's the heart of why we think this is so important, because while we can have our BI tool like Lumira make sense of the data for the analyst, we need a fast way to get this data to the user. And by making use of Spark SQL, we're actually able to go ahead and do that. So now, the next screen I'm going to show you here is actually how do you connect Lumira to Spark. And so here are the key things that you need. For Lumira, you're going to need SAP Lumira 1.2.1 or higher. Okay. You're also going to need the Simba-Spark ODBC driver. Okay. Actually, these slides will become available, so you can go ahead and click on the links to get access to it. And I apologize if you're seeing my virus definition updates. By the way, I apologize for that. And then also there's Simba's Universal ODBC. This basically is Simba's Universal ODBC direct access driver for Spark. And then you can also look at the Simba-Spark extension for SAP Lumira. This is a free download that allows Simba-Spark ODBC driver to work with Lumira. Okay? And so here's a couple of quick screenshots to show you how relatively easy it is for you to basically access this data set. So in order to connect Lumira to Spark, basically in your preparation, when you connect to a new data set, what you do is instead of specifying your text or your copy from clipboard or HANA or BO Universe or SQL, right there on the bottom you have an external data source. And you click on that. Because you've already set up the ODBC driver for via the Simba-Spark ODBC driver, you're able to go ahead and see that little Simba-Spark right there on the bottom right actually as one of your external data sources. Once you do that, next screen, boom, the data is extracted. And what's going on here basically is because I have data initially created with Spark and Spark SQL, but I saved it in the Hive Metastore, so that way I have a permanent table. That table is now accessible through the Thrift driver access. And so what happens is that Lumira is actually making use of Simba's driver to connect to the Thrift server to get to that data. Now that's probably a little too geeky for most, but still, nevertheless, the idea is that the data that is now sitting in your Hive Metastore is actually making use of Spark to access and get that data quickly into Lumira. And that's why we're able to go ahead and generate these queries so quickly, because the extraction process is significantly faster than the original overhead that we had to do when we originally were grabbing the data right out of Hive. Okay, so now we're going to get into the bulk of it. So the screens aren't going to change that much just because I actually have quite a bit to talk about on just this particular scenario. So if you look at the concept of expense categorization, that sounds rather boring. In fact, let me switch gears even a bit. If you're, too bad none of you can go ahead and raise your hand so I can see this, but how many of you actually enjoy filling in your expense reports? I'm just curious. So I'm going to pause, but I'm going to guess that just about nobody here in this webinar has raised their hand to say, oh yeah, we love filling out expense reports. Okay. Well, wouldn't it be nice if we can take a picture of your receipt and then we can automatically OCR it to be able to read the information in front of us. So for example, if you look at this receipt in front of you, I have to be automatically able to read this receipt, the Starbucks receipt that I have, which happens to be in my building, by the way, OCR it, automatically categorize it. And what I mean by categorize it is, remember, when you fill out an expense report, you don't typically just have to type in the amount, in this case $62, but you have to type in the vendor name, like Starbucks. You also have to type in the category. Oh, it is a beverage or it is a meal. So wouldn't it be much cooler if I could just take a picture of the receipt, automatically fill in the vendor Starbucks, automatically fill in the amount of $62.40, automatically fill in the expense category, that it's a beverage or it's a meal, depending on your company, the way your company works, and basically pre-fill the expense such that it's only a couple of clicks for you to go ahead and fill out the expense report as opposed to typing all this information in. If I was to be able to tap into the crowd that's here, I'm guessing a lot of you would love that, right? I'm going to assume yes. So, well, we're actually pretty close to reality with this right now. Concur actually has a product called Expenses, which does exactly this, which is take the picture receipt with your mobile phone, we OCR, we extract tokens, the meaning out of the receipt, such as the vendor name, the amount subtotals, and also to figure out how to categorize the stuff. Okay, excuse me, and we pre-fill the expense report, which is great. But this is not just for the simplification, to make it easier for you, the user, to go ahead and actually fill in their expense reports. It's actually really important for companies, actually, to go ahead and actually do this, because they're going to save a lot of money on their expenses because of the different taxation rules and different deductions with the different categories of spending that you'll actually have. Okay, so remember, different companies have different taxation rules for different industries and for different countries that they're in. In fact, we actually have a scenarios where if you as a business traveler typically travel to different countries, and if you fly to a country and you stay in that country too long, you actually have to be concerned about the fact that you start paying taxes to the country that you're visiting because you're there too often. And so by us actually being able to extract out this information, you detect the fact that you actually are filing expenses or booking flights or itineraries in different countries, we're actually better able to tell you, hey, you're about to cross the boundary or stay in a place too long, such that you start owing taxes to that. So these are very important things for you, the business user, and also for the company itself. So this categorization that I'm referencing is important for not just the user themselves, because it's a lot easier to type all the stuff in, but it's also really important for the company itself. So in this example, here's my receipt from Starbucks, like I said, and I want to quickly categorize it to an expense category of meal or beverage instead of like office supplies or travel. In fact, there are many companies that have tens or hundreds of different expense types, and so being able to automatically fill out this information will make your thumb a whole lot easier, because you're not scrolling through tens or hundreds of different expense categories. And so what's great about Spark is that we can actually use Spark's MLlib. MLlib is a scalable machine learning library, so we can test all sorts of parallel distributed algorithms to determine which is the best model we actually want to work with. Okay, and even more important than that is that from an engineering standpoint, we're using the same foundation that we use for Spark SQL. So the same foundation that we're using to deliver this data from to Lumira so quickly is actually also being used for allow us to categorize this data so quickly. Okay, so if you're still with me, for those who are technical geeks, here's basically a quick view of the Spark shell. Yes, and so for most of you, this is the reason why you love Lumira, because you don't actually have to look at this. You're not worried about actually typing in code, right? But for those who are more data scientist-y or engineering-based, they're going to love the fact that they can quickly access the data through the shell. And so, so there's only 2 screenshots, so don't worry, I'm not going to overdo it here. But so what you're seeing here is that the Spark shell is running a couple lines of Scala code. The first line is the val receipt is to basically extract one of the receipts, in this case the Starbucks receipt, and the second is to go ahead and just to do a quick row count, number of rows, by simply typing receipt.count. And you'll notice really quickly there are about 30 rows of text within this receipt. Excuse me, please. And so while we're not really showcasing MLlib right now in this case, in this particular example, by the way, this was actually presented at a previous CL Spark meetup session, and the slides are actually available on the meetup site itself. So for any of those who want to dive into some of the details behind how we actually use MLlib, please go there. Just that for the purpose of this session, we're going to stick to word count. And so while the first few statements allow me to get the count of the distinct words, what the last 2 statements here that you have, val word count and word counts take here, is actually what's most interesting, okay? Using this particular example, what you'll notice that I'm actually simply just doing a quick query that allows me to extract out the most common set of words that are inside this receipt. And so if I build a dictionary that removes common words or common spaces that are noted in red and blue, such as the double quotations, which basically means space or null, with card new, okay, if I build that, and I only keep the words that actually provide context, like Frappuccino, roast, topped, and Starbucks, okay? Now I can easily build a classifier to categorize a receipt with these particular words, such that when I'm trying to categorize the receipt, I can pull out these specific words and then know how to automatically categorize this receipt to say that, oh, in this case, it's a beverage because I see Frappuccino, roast, top, and Starbucks. Okay? Now, as I said, this is a bit of an oversimplification of a very hard problem, but nevertheless, I do hope it sort of showcases the power of Spark that allows me to jump from one problem to another problem very quickly and seamlessly, all with using the same foundation. And so, as the last little call out here, okay, as you can see from the two previous examples, we were able to quickly get the data to our analyst tool, Lumira, through our ODBC bridge by Simba using Spark SQL. And while a word count example is pretty fundamental, the context is that we're able to utilize various portions of the Spark ecosystem, to be able to go ahead and generate recommendations. And in our case, we're using Spark MLlib. But this is just part of the workflow. In reality, our workflow actually is a little bit more complicated. It actually makes use of Spark GraphX, which allows us to build a graph based on users' dining preferences and where they've gone. We then go ahead and use Spark MLlib to go ahead and categorize the various receipts that we get from these different restaurants, so we can know if it's lunch, if it's dinner, is it good for groups, good for business meals, things of that nature. And then we can go ahead and switch over to Spark SQL to present this data so our users, our analysts, can go ahead, who have the domain knowledge behind this stuff, who might not necessarily have the technical knowledge to be able to write a Scala or Python query, or Java query, but they actually have the domain knowledge to be able to say, okay, wait a minute, I'm looking at the data that you classified or looking at the graph that you went ahead and designed that represents the cuisine types, and in fact, you know, I'm seeing some issues here, or I'm recognize the fact that this particular restaurant should really be, is actually really good for restaurants, even though all the indicators say it's not. And so the idea of this workflow is that we incrementally update by jumping back and forth between Spark SQL, the analyst, to work with Lumira against that data, to GraphX, which allows us to go ahead and update the cuisine information as it progresses, to Spark MLlib to update the categorizations, because as time progresses, as more customers come in, as new restaurants appear, we're going to have to keep on incrementally updating the models that we're working with and updating the recommendations and categories that we're working with. So as new discoveries are being made and we're gaining new insights to our data, we can incrementally update each one of these models as those discoveries are being made. It's a continual cycle that allows us to quickly extract meaning from our data, and as we better understand it, we have multiple tools within the same Spark framework that allows us to improve our understanding of this data. And so, yes, we can consolidate using our Hadoop cluster, but from that point onwards, we've been to visualize, to gain insight, to recommend. We use Spark as our framework, we use Simba as our bridge, and we use Lumira as the way to visualize all this data. And I'd like to leave you with one last quote, a quote from Wrangling, who's one of the founders of Databricks, who sums up the power of Apache Spark quite nicely. Spark is the Swiss Army knife of big data analytics. Okay, I think that's it for me. Back to you, Toph.
Thanks, Denny. Much appreciated. Make sure here we can see my screen. So a couple of thanks, Denny. Thanks very much. Appreciate it. Really appreciated the explanation of the connection from the technical expertise to the domain expertise. We're happy to contribute to that even in a small way on the Simba side. A couple of questions that we can address. The first one, apologies, I deleted it from the chat window by accident, but will this be available after the session? We'll make this recording available at simba.com, I hope by the end of the week, but more likely early next week. I'll also try to throw up a blog post that includes a PDF version of the slides themselves. In the meantime, if you're interested in the free Simba Spark extension, just do a quick Google search on it. It'll take you to a blog post written by my colleague Kyle Porter, and you can download the Spark extension from there and get details in that blog post. A couple of other questions here. Angela, this first one is for you. To what other data sources can SAP Lumira connect?
That's a really great question. So right out of the box, we offer connectivity to a lot of things. We can pretty much connect to anything that's got a Simba driver. So you can either use the out-of-the-box connectivity, or if it's a data source that doesn't connect out of the box to Lumira, we do have an open access SDK that would allow you to connect to additional data sources. But just a handful of the ones that are available out of the box are Excel, you can load from a text file, SAP HANA, Business Objects Universes, SAP Business Warehouse, and then of course we've got the freehand SQL option where you can load data sets. So like we've got some Salesforce.com drivers as well as Cloudera, and some Hadoop ones as well. But yeah, if anything's not on there, you can use the SDK for access as well, but there is a lot available out of the box thanks to the drivers from Simba.
Excellent. Thanks, Angela. Denny, question for you, technical question. Was there any table caching predefined in Spark SQL before any query occurs? And what is the data type, JSON, Parquet, Avro, et cetera, you use in the comparison?
Okay, so the first part of the question, did I actually purposely cache the SQL tables? In this case, I did not actually go out of my way to cache any of the tables. But you are correct with your question, which is to say that to improve performance, I could have actually basically tried to cache the tables before extracting the data, but it's not actually as straightforward as that. So for now, I'm not doing that, okay? The second part of the question, I believe, is what in terms of, are you actually asking me in terms of extracting the data, what format it is? Basically, if that's the question, then initially, actually, we did this all off of text files, in fact, because we were, to be candid, quite lazy, actually. But over time, we've actually progressed and put everything inside Parquet. And so most of the data we have here right now is relatively relational. You know, looks like it sounds like a table. But actually, the newer data sets that we're currently working with actually have much more JSON-like because we have actually a lot of nested JSON in our Parquet files now. I hope that answered that question.
Cool. Thanks, Denny. One more question for you, Angela. Does Lumira allow SQL Server database directory, or do we need to use the SDK? And if so, where can I find the SDK?
So SQL Server database, I am just checking if that one is available out of the box. I believe that one is. Yeah, I think SQL Server is in there. I'm just looking for it now. And if not, you can find the SDK on SAP SCN.
Great. Thanks, Angela. Last question for you, Denny. When's the next Seattle Spark meetup?
Actually, excellent timing. In fact, the next Seattle Spark meetup, in fact, is tonight at AVO offices in downtown Seattle. If you're interested, please come to just Google it, Seattle Spark meetup. It should be up there near the top, and try to register in.
Okay, and with that, I will wrap up this, our second in our series of joint SAP Simba webinars. I really want to thank Angela Harvey and Denny Lee for contributing today. I think it was a very valuable presentation. I certainly enjoyed participating. Look forward to the next one. Thanks all, and as noted, the webinar will be available on in a recorded fashion on concur.com, excuse me, simba.com, maybe concur.com as well. In addition, I'll post a blog including a PDF version of the slides from today. Thanks all. Look forward to the next webinar. Bye-bye.
Thanks.